First, I'm going to discuss the topic of balloons. I'm going to start off with a little bit about force. When you inflate a balloon, you blow it up like this, and then you release it, the balloon goes flying around the room. Before releasing the balloon right now has zero total momentum. When you let the air come out, when I let go of this, it rushes out with high speed and pushed by the compressed air, and it pushes back, causing it to go in the opposite direction that the air is coming out. This pushes back on air and pushes the air on the balloon. The two momenta are canceled, and that's why they go in the opposite directions. Like, for example, the balloon goes around the room. Next, I'm going to discuss hot air and helium balloons. Hot air expands as it takes up more volume when compared to an equal mass of cool air. Density of hot air is less than cold, which is why you use hot air to make a hot air balloon rise. Hot air is lighter than cool air as it has less mass per unit of volume. Actual hot air is called an envelope. To lift 1,000 pounds worth of weight, you need almost 65 cubic feet of heated air. So the more weight that's in here, the more hot air you're going to need, which is why a hot air balloon is so big. To keep the balloon in the air and rising, hot air needs to be propelled upwards into the envelope using the burner. The burner right here on the hot air balloon pushes the air up, causing the balloon to continue to rise and filters down the cool air. The reason that the hot air causes this to float is because less dense air floats. Heavier fluid or gas falls and flows under the less dense object, pushing it upward, which is what I was discussing, how the hot air flows up and causes the cool air to be pushed down and out as it continues to filter in a circle. If you fill a balloon with hot air, it will rise until reaching an altitude at which the density of surrounding air matches that of the balloon. So hot air is going to continue to rise, but it's not going to rise forever. Once it gets to that area where the air is equally dense, then it's going to stop and just stay at that level. Helium is better than hot air, though. Hot air has to be so big in order to lift the amount of mass they do. Like, if I had another person in here, you'd need even more hot air. And the amount of hot air just depends on the amount of weight, the amount of mass. Hot air, as long as helium plus the balloon is lighter than the air it displaces, the balloon will float. Helium, on the other hand, weighs 0.1785 grams per liter. That's a lot lighter than hot air. Helium works by the law of buoyancy. Helium is so much lighter than air because helium atoms are lighter than a nitrogen atom. They have fewer electrons, protons, and neutrons than a nitrogen atom do, making them a lot lighter. Approximately the same number of atoms of each of these elements fill approximately the same amount of space, and therefore the gases made of lighter atoms are lighter, which would explain why it'd be better to have a helium hot air balloon, but it would have to take a lot of helium in order to lift this, so hot air is using the burner is a lot easier. That is my topic of balloons.